Introduction to Cloud Identity. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Today we are diving into Google Cloud Identity, specifically focused on managing users and groups. We will cover both manual administration through the console and command line, as well as automated provisioning at scale using directory synchronization and standards-based protocols. Cloud Identity is Google's identity as a service offering, also known as IDaaS. It is the foundational identity layer that sits underneath everything you do in Google Cloud, Google Workspace, and any third-party application you connect through single sign-on. Understanding cloud identity is critical because every user, group, and even service account in your organization ultimately gets authenticated and managed through this platform. There are two tiers available. The free edition gives you basic user lifecycle management, group management, security center reports, basic mobile device management, and single sign-on to thousands of pre-integrated SaaS applications. The premium edition adds advanced enterprise mobility management, advanced security features like context-aware access, automated user provisioning to third-party applications, secure LDAP, and longer audit log retention. One important distinction to keep in mind throughout this presentation is the difference between Cloud Identity and Cloud IAM. Cloud Identity is about who can authenticate, meaning who the user is. Cloud IAM is about what that authenticated identity can do, meaning what permissions they have on Google Cloud resources. Both work together, but they are separate systems with separate management surfaces. Manual user creation via Admin Console. The most common way administrators create users when starting out is through the Google Admin Console at admin.google.com. This is the web-based administrative interface for both Cloud Identity and Google Workspace, and it works well for small teams or one-off user creation tasks. Let me walk you through the sequence of interactions that happen when an administrator creates a user manually through the console. The flow begins when the administrator navigates a web browser to admin.google.com. The Admin Console responds by prompting for authentication, requiring the administrator to sign in with their privileged account, typically a super admin or user management admin role. The administrator submits their credentials, and the Admin Console validates them against the Cloud Identity backend. Once authenticated, the console displays the main dashboard, and the administrator clicks on the Users section. The administrator then clicks the Add New User button. The Admin Console responds by displaying the new user form, which requests the user's first name, last name, primary email address, optional secondary email for password recovery, and an organizational unit assignment. The administrator fills in the user details and submits the form. The Admin Console sends this data to the Cloud Identity API, which performs validation on the email address to ensure uniqueness within the domain. The Cloud Identity API then creates the user object in the Cloud Identity directory. Once the user is successfully created, the Cloud Identity API returns confirmation along with either an auto-generated temporary password or a password chosen by the administrator. The Admin Console displays this password to the administrator, who must securely communicate it to the end user, typically by sending an automated welcome email through the console. The end user receives the welcome email containing their username and temporary password. They click the sign-in link, which directs them to accounts.google.com. After entering the temporary password, Cloud Identity forces them through a first login password reset flow, ensuring the administrator no longer knows the user's actual password. The user then gains access to Google Cloud and any Google Workspace services they have been licensed for. Creating groups manually. Groups are the backbone of scalable identity management. Instead of granting permissions to individual users, you grant them to groups and manage membership separately. This dramatically reduces administrative overhead and makes auditing far simpler. Cloud Identity supports two main flavors of groups: each serving distinct purposes. The first is Google Groups, sometimes called email groups or distribution groups. These are addressable by email, meaning you can send emails to the group address and all members receive them. They are used for both communication and permission assignment in Google Cloud IAM. Most organizations use this group type for both purposes simultaneously. The second is security groups, which are a special class of Google groups specifically labeled for security-sensitive use cases. They cannot be joined by external members or have content forwarded outside, and they appear distinctly in audit logs. Security groups are recommended whenever a group is used to grant access to sensitive resources, regulated data, or administrative permissions. Let me walk through the gcloud commands shown on the slide for creating these groups programmatically. The first command is gcloud identity groups create. This is the primary command for creating any group in Cloud Identity. The first positional argument is the group's email address, in this case engineering@example.com. This email becomes both the group's identifier and its mail address. The -- organization flag specifies the Cloud Identity customer ID, which scopes the group to the correct tenant when you have access to multiple. The -- group display name flag sets the human-readable name shown in directories and the admin console. The -- description flag adds a longer text description explaining the group's purpose, which is invaluable for governance and audit reviews months or years later when no one remembers why a group was created. The second command shows how to create a security group. It looks nearly identical, but adds the -- labels flag with the value cloudidentity.googleoffice.com/groups.security equals empty string. This special label marks the group as a security-sensitive group, applying the additional restrictions I mentioned earlier and ensuring it appears in security audit reports. After creation, the group exists in the directory but has no members. Membership is managed as a separate operation, which we will cover in the next slide. Bulk user provisioning with CSV. When you need to onboard dozens or hundreds of users at once, perhaps during an acquisition, a new department launch, or initial cloud migration, manual creation is not practical. Cloud Identity provides bulk user provisioning through CSV file uploads in the admin console. The CSV format follows a strict schema. The header row defines the columns, and each subsequent row represents one user to be created. Required columns include first name, last name, email address, and password. Optional columns include org unit path for placing users in the correct organizational unit, recovery email for password recovery, recovery phone, employee ID, department, and dozens of other attributes. Let me walk through the CSV example shown on the slide. The first row is the header, listing the column names. Notice that column names are case-sensitive and must match exactly, including spaces. First name and last name are straightforward. Email address is the primary login email and must be unique within your domain. Password is the initial password for the account, and it must meet your organization's password complexity requirements. Org unit path uses the /separated path syntax, where / by itself means the root organization, and /engineering/backend means a nested organizational unit. Recovery email gives users a way to reset their password if they get locked out, typically pointing to a personal email. Change password at next sign in is a Boolean column accepting true or false. Setting this to true forces users to choose their own password on first login, which is strongly recommended so administrators never permanently know user passwords. The data rows then list each user. For example, the first data row creates Alice Smith with email alice@example.com, a temporary password, placement in the /engineering org unit, a personal recovery email, and the password change requirement enabled. Once your CSV is prepared, you upload it through admin console at users, then bulk update users, then add multiple users. The console parses the file, validates each row, and reports back any errors before processing. Successful rows result in immediate user creation, while errors are surfaced so you can correct them and re-upload. This approach works well for one-time bulk operations, but it is not a synchronization mechanism. If a user already exists, the upload will either error or update existing fields depending on which CSV upload mode you choose. For true synchronization with an existing source of truth like Active Directory, we need a different tool, which we will cover next. SIM Automated Provisioning. For organizations that have moved beyond on-premises Active Directory to a cloud-native identity provider like Okta, Azure Active Directory, or Jump Cloud, the modern automated provisioning standard is SIM, which stands for System for Cross-Domain Identity Management. SIM is an open standard, currently at version 2, that defines a REST-based API for synchronizing user and group identity data between systems. Let me walk you through the SIM provisioning flow step by step. The flow starts with an HR system like Workday, Bamboo HR, or SAP SuccessFactors. This is typically the corporate source of truth for who works at the company, their employment status, their department, and their role. The HR system sends a hire event to the identity provider, in this example Okta. The hire event communicates that a new employee has been added to the HR roster, triggering downstream provisioning workflows. The identity provider processes the event and creates a user in its own directory. This user gets all their core attributes populated from the HR system, including name, email, manager, department, and any group memberships derived from their role. The identity provider then evaluates assignment rules. Based on the user's attributes, the IDP determines which downstream applications the user should have access to. For users who should have Google Cloud access, the Cloud Identity application is assigned to the user. Once Cloud Identity is assigned, the identity provider sends a SIM provisioning request to Cloud Identity. This is a REST API call to the SIM endpoint, specifically a POST request to the user's resource with a JSON payload containing the user's attributes formatted according to the SIM 2.0 schema. Cloud Identity receives the SIM request and creates the user in the Cloud Identity directory. It returns a SIM response with the created user object, including the unique Cloud Identity user ID. The identity provider receives the response and stores the Cloud Identity user ID in its own database, linking the IDP user to the Cloud Identity user. This mapping is critical because future updates, like a department change or termination, will use this ID to target the correct Cloud Identity record. The flow continues with the user logging into a Google Cloud Console session for the first time. The console redirects the user to the identity provider for authentication, since SSO is configured. The user authenticates with the identity provider, which sends a SAML assertion or OIDC token back to Google Cloud, completing the sign-in. The user lands in the Cloud Console with all the permissions assigned to them based on their group memberships, all without ever needing manual provisioning. When the user is terminated in the HR system, the reverse flow happens. HR sends a termination event to the identity provider, which sends a SIM deactivation request to Cloud Identity, suspending the user's account and immediately revoking all access. This is the gold standard for identity lifecycle automation. Best practices and lifecycle management. Now that we have covered the manual and automated approaches to managing identities in Cloud Identity, let me consolidate the key best practices that will save you significant pain in production environments. First, never grant IAM permissions directly to individual users. Always grant permissions to groups, and manage user membership in those groups. When someone joins, leaves, or changes roles, you only need to update group membership rather than chasing down dozens of individual IAM policy bindings scattered across projects, folders, and the organization. This single practice is the difference between manageable and unmanageable cloud environments. Second, designate a single source of truth for identity. If you have an HR system, that should be the origin point. From HR, identity flows into your identity provider, and from there into Cloud Identity. Avoid creating users directly in Cloud Identity if you have an upstream system, because divergence between systems creates audit gaps and operational headaches. Third, use organizational units to mirror your business structure. Org units in Cloud Identity allow you to apply different policies to different segments of your workforce, like requiring stronger two-factor authentication for finance users or different password complexity for engineering. Plan your org unit hierarchy before bulk loading users, because moving users between org units later is more friction than placing them correctly the first time. Fourth, separate your administrative accounts from your daily use accounts. Super admin permissions should never be granted to an account that also reads email or browses the web. Create dedicated admin accounts like Alice Admin at example.com that you only use when performing administrative tasks, and enforce hardware security key two-factor authentication on those accounts. Fifth, label your security groups using the cloudidentity.googleoffice.com/groups.security label. This makes them appear in security audit reports and applies the additional restrictions that prevent accidental exposure of sensitive permissions to external members. Sixth, regularly audit group memberships. Use the admin console reports or the directory API to extract group rosters and review them with the resource owners. Stale memberships are one of the most common findings in security audits. Seventh, automate everything you can. Bulk CSV uploads are fine for one-time operations, but ongoing operations should use GCDS for on-prem rooted directories or SIM for cloud IDPs. Manual click ops at scale creates inconsistency and audit gaps. Eighth, plan for deprovisioning, not just provisioning. The harder problem is not creating users. It is ensuring that when someone leaves the company, every access they had is revoked promptly. Automated provisioning systems handle this automatically through suspension and deletion workflows triggered by HR events. That covers the foundation of cloud identity user and group management. We have walked from manual console operations through scripted CLI commands, bulk CSV provisioning, on-premises directory sync with GCDS, and modern SIM-based automation with cloud identity providers. Thank you for your attendance. Please consider subscribing to the channel and liking this video.